Hey YouTube, Josh here with Tipsy Python, your casual guide to learning how to code with Python. My goals for today's video are to talk through conditional statements in Python while demonstrating how to use the if, elif, and else keywords, as well as going back to the sales tax calculator app that we started and adding some additional functionality to allow for different user inputs. And in today's video, I'm featuring Eagle Rare Straight Bourbon. Now you're probably asking, is it that rare? And I don't know, did the guy specs tell me to take 2 years on a wait list to get one? Yeah, he did. Now, it's not really that rare, but it's definitely not easy to find, and it is very easy to enjoy. So let's enjoy some today while we're learning how to code. I hope you're ready. I was born ready. Let's get into it. Right after a little sip, of course. Let's take it straight to Jupiter. I hope everyone remembers this guy that we talked about a while back, the Boolean data type. And if you'll remember, Boolean is a binary data type. It has 2 states, true and false. And be very careful, Python is case sensitive, so when you type true and false, make sure you use uppercase T and uppercase F. Now today's video is very important because if statements are the logical cornerstone of programming. If programming was a train, the if statement is the switch on the train track. If you don't have this one right, your program is not going where you thought it would be. And in true Tipsy Python fashion, let's just get into it. An if statement looks like this. If true, colon, new line with a 4-space indent, and your action. And let's examine this piece of code. The if statement, unsurprisingly, begins with the keyword if, followed by an expression that should evaluate true or false, then a colon. Then we have our 4-space indented block of code. Remember, this could be 1 or more lines. And here it's the code inside the indented block that's conditionally executed. If the expression evaluates to true, then execute this piece of code. And of course, as you know, Python will blow up if we don't have anything in our indented block. So here we're using pass as a placeholder that does nothing, it just moves on. We're gonna switch it up though and have the code actually do something. So instead of pass, I'm gonna have a print statement that says this works, and I execute. And because my expression evaluated to true, the code inside the indented block was executed. Now on the other hand, if the code evaluates to false, the lines inside of the indented block are not executed. In Python being an indented language, we can control the flow of our program by having multiple lines both inside the indented block as well as dedented back in the main flow of the application. Let's just show that. So I'm going to have a second line of printing that's going to happen only if this evaluates to true. And then we're going to jump back to the main loop and print main. So even if our expression evaluates to false, my program continues running. However, if it evaluates to true, everything inside the indent block happens. Now, if statements are typically not hard-coded true or false. They're more often used as a device to evaluate a condition and then determine what happens next. And the foremost way to do this is with comparison operators. Let's take a look at a few of the common ones here. A comparison operation can look something like this. Now 1 is greater than 0, so this expression returned true. We could also use 1 is less than 0, which evaluates to false. And if they're equal, syntax error, can't assign to literal. This is a good one to understand. In Python, a single equal sign is an assignment operator. The comparison operator, on the other hand, is 2 equal signs. Let's take a look at that. We can check is 1 equal to 0. A few of the other common ones that you'll see are is 1 greater than or equal to 0? Is my first variable less than or equal to 0? And are these two things not equal? Now again, I'm hard coding values, which in real programming we do not do very often. Instead, we're going to use these comparison operators in conjunction with an if statement. Let's write our first real one right now. Let's pretend that we have some variables like your hand equals 20 and the dealer hand equals 21. In this case, I'm channeling the logic of a blackjack game where we're going to compare the dealer's hand versus our own hand. Something like this. If dealer hand is greater than or equal to your hand, print the house wins. And then once the if statement's set up, the program is a lot less about the logic and a lot more about just manipulating the variables. Okay, pretty comprehensible example so far, but you'll notice that we're only handling if the dealer wins. What if That statement of logic evaluates to false and we win, and we need another action to happen that won't necessarily happen every time that we exit the if statement. And this is where our good friend else comes in. Going back to the code, we can actually add a second clause on here and say else print you win. And the important thing to understand about if and else is that they are mutually exclusive pieces of code. If the if happens, the else is not executed. Now executing the code again, you'll see that now we have a condition that only happens in the event that your hand wins. And I guess I just like using integers because it's a clean comparison, but the comparison operators can be used in many cases. For instance, let's take a look at a couple string comparisons. I can do an equality check like, does A equal A? And it returns true like we would expect. And like most things in Python, this is actually case sensitive. Now, one more thing on string comparison. I really don't recommend that you do this because there's a lot of ways to do a sort in Python, but if you really must, we can compare lexicographical order with the greater than less than operator. So I can say, is A less than B? If you're someone that's new to Python and programming, I think it's very important to see this and to understand that it's one tool in the toolbox that you can reach for, but it's not one that I reach for very often. And hey, let's get crazy. While we're in the neighborhood of conditional statements and patterns that I personally don't use very much, Python also has a concept of truthy and falsy. What that means is that Python objects have an optional attribute that allows them to be truth tested. An attribute which allows them to be truth tested. Let's just see what that actually means. I'm going to use another function called bool. And this function actually returns the Boolean value of an object. In the case of strings, any string returns true, and an empty string returns false. Each object works a little bit differently, so if I say Boolean of 0, I get a false. If I say Boolean of 1, I get true. And almost counterintuitively, to me anyways, Boolean of negative numbers is also true. See why I don't use them much? That just doesn't make sense to my mind. But hey, for you, if it feels good, do it. I guess in all honesty, there is one that I reach for sometimes. There's an object I haven't talked about very much called none. As you can see here, the none object returns false when truth tested. So I do use this sometimes when I have a variable. I'll initialize it as none, and if I expect a string to be in it, I can truth test it to see if it's still none. There are certain code patterns where sometimes we see this. Let's suppose that we initialize a price variable at 0, and then some logic happens. And we can perform a simple truth test like, if price, print, you are being charged. And a case like this is actually a pretty good fit because no matter how many times I run it, the only time that I'll be charged is if a price is actually set. And as I keep talking about, values in Python are rarely ever hard-coded, so let's set a couple of variables and we'll start comparing those. I'm going to set a couple user variables, and I'm just going to do this in one line. User 1 is Bobby, user 2 is Sally. Now I can compare if my two user strings are the same using the equality operator. And as we introduce more users to our program, we can keep something like this going. Now remember that Python is case sensitive, so a lot of times when I'm doing string comparison, we want to account for that. There's a nice method that string has called upper, and there's a lower as well that does the same thing, but upper sets a string to uppercase, lower sets it to lowercase. When I'm doing a comparison like this, I'll often perform upper on each string so that I make sure they're the same case, and then I can get a real comparison value for them. Another common scenario that comes up when programming is having to perform a membership test. This is when I have to check if an object is a part of a collection, for instance, if an email is a member of registered email addresses. And of course we can accomplish this really easily in Python using the keyword in. Now let's suppose that I had a list of pals, and I had a pal named Jack. I could perform a test like, if this pal, using the keyword in, pal list, we'll see if it's a member of it. And we weren't really expecting anything here because we know that this pal Jack's not a member of pal list. And let's actually check the inverse to make sure that he's not a member. And as our data gets bigger, the if statement becomes a very powerful construct when we combine it with loops. Let me generate some data to illustrate this. I'm going to have a new pal list and a list of these pals I need to evaluate. Now I want to make an identical check for each piece of data, so I'm going to start with my iteration for pal and these pals. And then I'm going to perform my conditional check. If pal is in pal list, print pal is on the list. So here I iterated through my new list of pals and I did a check to see if each one of these people is in the original list that I had. Only Jill was returned. Now suppose they're not on the list and we wanted to add them. We could add an else in here. And when we execute here, we see that the print was only executed for the member that was already in the list, and for everyone else, they hit the else statement. They're not in the list, so we appended them at the end. And now is actually a pretty good time to introduce one more member of the if statement family. We have if, else, and elif goes in the middle of them. Elif is another conditional statement that only occurs if an if or elif above it has not been executed yet. To illustrate this point, let's do an elif check for Tipsy Joe. I'm going to rerun this line of code so that my variables are reset, and then I'm going to add an elif specifically for Tipsy Joe. As we're iterating through these pals, elif pal equals Tipsy Joe, print not today, Tipsy Joe. Let's recap one more time what's happening as we're iterating through these pals. First we found Jill. If Jill is in pal list, which she is, the print statement was executed and the rest was skipped. Then we dropped back to our loop, we iterated to Jimmy. If Jimmy's in pal list, he's not, so we pass. Else, if Jimmy equals Tipsy Joe, he's not, so we pass. So now we hit the else and Jimmy has been appended to the list. We pop back out to our iteration, finally grabbing Tipsy Joe, and he finds his place right at the elif statement. And the results are shown here. Not today, Tipsy Joe. Alright guys, I know we're crunching a lot today. You're doing great. We have one more concept to round things off, and it's the while loop. The while loop is just another type of truth check, and they look like this. While true, pass. And you'll actually notice that this piece of code has not stopped executing yet. It's still looping, and it will go on forever. I mean, I'm playing, not really though, I am going to stop it. The while loop is just a conditional check that says keep executing as long as this expression evaluates to true. And that's why we use it in our command line interface code. We never want that prompt to end. After action is performed, we want it to start again from the top. To better understand the while loop, as well as to get some practice writing conditional statements, let's enhance the sales tax calculator that we've been making. We're going to add a few user choices this time. We're going to say the user has a choice to calculate a single item, the user can view the history, or the user can exit the program. As usual, I'm going to bring up Sublime to edit my script. I'm thinking the first thing that we can refactor is the while true. We can pull this out, have a variable called running. And instead of referencing a hard-coded true, we can check the truth of the running variable. And then of course we have to change our prompt. If we're actually going to give the user some options, let's show these choices on the first input. We're going to change it to something like enter item E, C history, H option, or exit. And being that it's a prompt, I'm going to give them a space at the end here. And now that we're giving the user some choices about what they want to do, we need to capture their input and then evaluate it and execute some other code conditionally. And I know I'm just jamming up the code with these comments, but we'll go back and clean that up later. And actually this isn't even a good variable anymore. I'm going to say user input, if user input, I don't think it matters if they put in upper or lowercase. If it's E, execute some code. If it's not E, maybe it's H. I'm going to do one more like that to check for the exit condition. And then we're going to use else to handle any cases that we don't understand. In this case, we'll just print a warning. Did not understand input, at which point the loop is going to recycle. And just make sure I am on the right track, let's execute this and see what happens. I need to print out this line, save. And when I execute it, what I'm expecting is that if the input is anything but E, X, or H, we're going to get this print statement. In the other cases, it's just going to pass and the loop is going to go back to the prompt. Let's test it out. In the event of E, H, or X, the loop just starts again. And for any other input, we get the warning message, did not understand input. Now that our conditional statement is working, let's build out the logic. Tax rate's always been a constant, so I'm just going to put that at the top up here. If the user wants to enter an item, let's give them the prompt here. User price is equal to enter the price of the item. Now we can reuse some of our old code. I'm going to save this and let's test out the enter item functionality. The price of the item, $71. We get our price back and the loop restarts. Let's code the next condition. If the user opts to see the history of prices, then we can just pull this line. I'm going to take out the slice so we can see the full history, and let's test that. History is blank on the first iteration. Let's enter an item, 60, and then view history. And finally, let's get at this condition if the user wants to exit the loop. Because the while loop continues as long as running is true, to exit, all we have to do is set running equal to false. Testing one more time. X closes our app. Enter item 50. I'll enter another item 45. Take a look at the price history, and as a user, I think I'm done here. And now we're getting somewhere. Now our program has some substance, and because we have this logical flow of events, it resembles a real application. And as some kind of IT professional, let me tell you, this is how code is really written. Sitting back, enjoying some good whiskey and writing code. Today I had the privilege of enjoying some Eagle Rare. Now this bourbon's actually 10 years old. It doesn't say it on the front anymore, but the age statement still remains on the back. Another thing about this bottle is it used to actually say single barrel on the front as well, and I think they went from manually bottling these to having some sort of machine that bottles them, and it's still done one at a time, but between the actual barrels there will be a bottle that has half of its contents from one barrel and then half from the next, so it can no longer designate itself as a single barrel bourbon. The nose on Eagle Rare is just super sweet. I describe it like corn syrup, white sugar, and bubble gum. And then taking it to the palate, you have all your staple bourbon flavors in there. You have vanilla, I got caramel, I got a little bit of barrel char turning to a brown sugar kind of thing. It's spicy, like a cinnamon spice, and then on the finish, applesauce. Eagle Rare gets a 10 out of 10 from me. It's one of my favorite whiskeys to enjoy. And guys, you get a 10 out of 10 for hanging in there and watching this video today. I know you're thinking you could have turned it off and just watched Ozark instead, but hey, that's on you. That wasn't my choice. All jokes aside, thanks so much for watching this video. I hope you enjoyed it, and if you do enjoy this type of content, please consider subscribing to my channel. If you're interested in seeing the code that I wrote today, I'm going to be posting this Jupyter notebook on my GitHub. And until next time, friends, Tipsy Python.